In this video, I'm going to be showing you a trick on how you can use electronegativity, in calculation of oxidation number. Now, this is a sketchy chart of the periodic table. You see, we have hydrogen to fluorine. Now, we know hydrogen has an oxidation number. It has a +1 oxidation number. When oxygen is directly attached to a metal, you have a -1. It carries a -1, while when it's directly attached to a non-metal, it carries a +1. Now, oxygen has a -2 when it's an oxide. When it's a peroxide, it has a -1 oxidation number, and when it's a superoxide, it has a -0.5 oxidation number. For halogens, that is fluorine, chlorine, bromine, and iodine, they usually have a -1 oxidation number. Now, the group 1 elements which are directly under hydrogen, that is, we have sodium, potassium, rubidium, cesium, and francium. This is supposed to be R. Francium, they all carry a +1 oxidation number. Now, if you look at this element, you see that their electronegativity, we have hydrogen has electronegativity of 2.1, and then fluorine has electronegativity of 4.0, making fluorine the element with the highest electronegativity on the periodic table. Electronegativity, it increases up the group and increases towards the left, right? Now, one thing I want you to also notice that the electronegativity of elements at their ground state, let's say fluorine, sodium, like the way they are now at their ground state, their oxidation number, not electronegativity, the oxidation number of elements at their ground state, like the way they are now, is always equals to 0. So if you have sodium, for example, the electronegativity will be equals to 0. Now, what if you have an element, let's say a compound, let's say methane? Methane, since the overall charge is 0, it's equals to 0. The overall charge is 0, the oxidation number is equals to 0. But what if you have a compound like this, CO3 -1? Now, the overall charge of this compound is -1. So the oxidation number, when you are calculating it, it will be equal to -1. When you solve for it, you then get the oxidation number. So, electronegativity is the ability of an atom to pull electron towards itself. So we are looking at electronegativity and how it's related to oxidation, or how it's related to calculation of oxidation number. So take for instance, we have hydrogen on the periodic table. We have hydrogen. Let me change this, my pen. We have hydrogen, we have boron, we have carbon, we have nitrogen, we have oxygen, and we have fluorine. Then we have chlorine, we have bromine, we have iodine, right? We have sulfur, we have phosphorus. Electronegativity increases up the group and also increases towards the left. So therefore, fluorine is the most electronegative element. Now, the electronegativity of oxygen is 2.1. The electronegativity of boron is 2.0. Electronegativity of carbon is 2.5. And that of nitrogen is 3.0. That of phosphorus is 2.1. Electronegativity of sulfur is 2.5. Electronegativity of oxygen is 3.5. And electronegativity of fluorine is 4.0. That of chlorine is 3.0. And that of boron is 2.8. And that of iodine is 2.5. So now, this is the electronegativity of these elements. If you look at it carefully, you see fluorine has 4.0, which means fluorine is the most electronegative element. Now, let's look at how this is related to calculation of oxidation number. Take for instance, we have oxygen difluoride, right? And you are to calculate the oxidation number of this particular compound. Now we know that fluorine has electronegativity of 4.0 and oxygen has electronegativity of 3.5, sorry. Now you see, between fluorine and oxygen, which has higher electronegativity? Fluorine, right? So fluorine will be partially negative while oxygen will be partially positive. Now what this means is that whatever element has the highest electronegativity in a particular compound, that element is the one that carries the negative charge, while the other element will carry a positive charge. Now in this case, and we know that fluorine usually is -1 when you are writing oxidation number. When you are writing oxidation number, fluorine, the halogen, fluorine, chlorine, bromine, and iodine, they always have a -1. They always have -1, right? We know oxygen to be carrying -2 on its own, and then it's carrying -1 as a peroxide, and it's carrying -0.5 as a superoxide, right? We know oxygen to carry +1 when it's attached to a non-metal, and it's carrying -1 when it's attached to a metal, right? So this is for oxygen, this is for halogens, and this is for hydrogen, right? Now pay close attention to these electronegativity values. Now because fluorine has the highest electronegativity, we say oxygen plus 2 fluorine is equals to 0, because the overall charge of this particular compound is 0, so it's equals to 0. Oxygen plus 2 fluorine minus 1 is equals to 0. Oxygen minus 2 is equals to 0. Oxygen is equals to +2. So you see, usually oxygen carries -2, but in this case, because oxygen is carrying the partial positive charge, the oxidation number is +2. Let's take another example. Let's say we have hydrogen chloride, right? Now we know that chlorine here has a 3.0 electronegativity value. That is En value. I can just abbreviate it as En value. 3.0 En value, and then hydrogen has a 2.1 En value. Therefore, chlorine is partially negative because it carries more electronegativity charge, and then hydrogen is partially positive. Therefore, we say hydrogen plus chlorine is equals to 0. The overall charge is 0. So hydrogen, just put hydrogen plus chlorine. Chlorine is -1, like we said earlier. -1 is equals to 0. Hydrogen is -1 is equals to 0. Hydrogen is equals to +1 when you carry it to the other side. Now, when written correctly, the element you are looking for, its oxidation number, is usually written at the left, while the one which you already get its oxidation number from the periodic table is written on the right. Now, let's take another example. Let's say we have sodium hydride, right? Now, how do we get the oxidation number of this particular compound? We know that hydrogen has an oxidation number of 2.1, while sodium has an oxidation number of less than 2, right? Therefore, hydrogen is partially positive, partially negative. It has more electronegativity, while sodium is partially positive. Now, when you want to write it, you say sodium plus H is equals to 0. The overall charge is 0. Now we know that hydrogen, since it's carrying a partial negative charge, you say sodium plus minus 1 is equals to 0. Sodium minus 1 is equals to 0. Sodium is equals to plus 1. Next, let's take barium hydride, right? Now, we know that boron has an electronegativity of 2.0. Boron has an EM value of 2.0. And then we know hydrogen has an EM value of 2.1. Now, therefore, we know that hydrogen is partially negative and boron is partially positive. Now, we say B plus 3H is equals to 0. Then B plus 3 open bracket minus 1 is equals to 0. B minus 3 is equals to 0. B is equals to plus 3. And you see, boron has a partial positive charge, and you see the oxidation number is plus 3. Now, what about hydrogen sulfate? Right, we have H2S. Now we know that in this particular compound, we know hydrogen has an electronegativity value of 2.1, and then sulfur has an electronegativity value of 2.5, sorry. Now, in this case, we say hydrogen is partially, okay, in this case we say hydrogen is partially positive, while sulfur is partially negative, right? Therefore, we say 2H plus S is equal to 0. 2 bracket 1 plus S is equal to 0. 2 plus S is equal to 0. 2, sorry, S now is going to be equal to 2 minus 2. So sulfur is having an oxidation number of minus 2. Now let's take another example. Let's say we have sulfur, we have a compound as this. Now we know that sulfur has an electronegativity value of 2.5. Now what about oxygen? Oxygen has an electronegativity value of 3.5. Right? Now therefore oxygen is partially negative and sulfur is partially positive. You see here sulfur was partially negative, but in this particular example sulfur is partially positive. Now to calculate for that, we say S sulfur plus 2O is equals to 0. Now we say S sulfur plus, this place in the bracket, plus 2 open bracket minus 2 is equals to 0. Sulfur minus 4 is equals to 0. Sulfur is equals to, when you carry this to the other side, it's going to be plus 4. This is the oxidation number of sulfur in this particular compound. Next, let's look at let's look at ammonia. Now, what is the oxidation number of nitrogen in ammonia? To calculate for the oxidation number of nitrogen in ammonia, we know that hydrogen has an electronegativity value of 2.1, just like we've written here. Now, what about nitrogen? Nitrogen has an electronegativity value of 3.0, an EM value of 3.0. Now, therefore, you know that nitrogen 3.0, hydrogen 2.1. Nitrogen is partially negative, while hydrogen is partially positive, right? So we say N plus 3H is equals to 0. We say N plus 3 is equals to 0. We say N plus 3 is equals to 0. We say N is equals to minus 3. Usually, when nitrogen, phosphorus, and sulfur carry elements that are more electronegative than them, those elements are the elements you are going to solve for. But you see, in this case, nitrogen is more electronegative than hydrogen. So let's take another example. Let's say we have methane, right? How do we find the electronegativity? How do we find the oxidation number of carbon in methane? Now we know that carbon has an electronegativity value of 2.5. Hydrogen has an electronegativity value of 2.1. Now, to solve for this part for carbon, they solve the oxidation number of carbon. We know that carbon plus hydrogen plus 4 hydrogen, by the way, it's equals to 0. The overall charge of the compound is 0. Therefore, we say carbon plus, put down here we know it's partially positive, partially negative, plus 4 multiplied by 1 is equals to 0. Carbon plus 4 is equals to 0. Carbon is equals to minus 4. Now let's look at the polyatomic ions. Let's say we have hydrogen. We have a compound like this carrying a minus 1 charge. Now, how do we find the oxidation number of sulfur in this compound? And by the way, let's look at their electronegativity. We know hydrogen has an electronegativity value of 2.1. Oxygen has an electronegativity value of 3.0. Sulfur has an electronegativity value of 2.5. Right? Therefore, we know that sulfur, since it's directly attached to oxygen, oxygen having an electronegativity value of 3.0, oxygen is partially negative, sulfur is partially positive, and so is hydrogen. Therefore, we say H plus S plus 3O is equals to minus 1. Right? Next, we know hydrogen is 1 because it's partially positive. So you just put 1 plus sulfur plus 3 minus 2 is equals to minus 1. Hydrogen, which is 1, plus sulfur plus 6. This is supposed to be minus, not plus, because you have plus 3 multiplied by minus 2. It is minus 6, which is equals to minus 1. Plus 6 plus 1 minus 6 is equals to plus 5. So sulfur is minus 5. It's equals to minus 1. Sulfur, you carry it to this side, is going to be equals to minus 5 plus 5 minus 1, which is equals to plus 4. So this is our final answer, plus 4. Here are 2 examples for you. Feel free to pause the video and find the oxidation number of chromium and also the oxidation number of carbon. Now for the first one, to get the oxidation number of chromium, you know potassium, by the way, is in group 1, and you know group 1 elements have 1 valence electrons, right? So potassium has a number from the periodic table you get as 1 to use in finding oxidation number. Now we know the oxidation number of the oxidation, we know the EM value of oxygen is 3.5. Now of potassium, we know is in group 1, is less than 2.1, right? Therefore, we know that in this particular example, oxygen, let's put down, oxygen is going to be electronegative than potassium and chromium, right? Because one, chromium is directly attached to oxygen, and oxygen is more electronegative. So we know that potassium carries a positive charge, plus 1. Oxygen carries a negative charge, minus 2. While chromium carries a charge we are yet to determine. Now, to do that, we say potassium 2K plus chromium plus 4O is equals to 0. Now we say 2, 1 plus chromium plus 4 minus 2 is equals to 0. So we say 2 times 1 is 2 plus chromium minus 8 is equals to 0. Now 2 plus 2 minus 8, we have chromium is equals to minus 6 is equals to 0. Chromium is equals to plus 6. Right? So this is going to be the oxidation number of chromium. What about the second example? Feel free to pause the video and try. What is the oxidation number of carbon in this second example? Now we know that oxygen has electronegativity value of 3.5, making it more electronegative. Carbon has 2.5. Hydrogen has 2.1. And we know hydrogen has a higher electronegativity value compared to potassium, because electronegativity, they go up the group and down the left, right, towards fluorine. Now oxygen will be electronegative, carbon will be electropositive, partially electropositive, and hydrogen will be partially electropositive. So we say potassium plus hydrogen plus carbon plus 3 oxygen is equals to 0. Now we say potassium, which is what, plus 1, plus hydrogen is also 1, plus carbon is what we are looking for, then plus 3O. Then plus 3O plus 3 oxygen, we have it to be minus 2. So it's going to be 3 minus 2 equals to 0. Now next we say 1 plus 1 is 2 plus carbon minus, this is going to be minus 2, 3 times 2 is 6, minus 6 is equals to 0. So we have plus 2 minus 6, carbon is going to be equals to minus 4 is equals to 0. Carbon is equals to, you carry this minus 4 to the other side, it becomes plus 4. Right? Now, there's another thing I want you to know, to pay attention. Understanding the polyatomic ions, understanding the polyatomic ion chart will help you in getting the oxidation number of compound much easier. So let's say for this first compound that we will give, for the second example, that is potassium HCl3, right? You can as well easily break that into 2. So we are going to have potassium having a partial positive charge, and then hydrogen carbonide having a partial negative charge, right? Now you can still break down this hydrogen carbonide, bring it down, you still break it again. Now we have hydrogen having a partial positive charge, and then we have a carbonyl group having a partial negative charge, right? Now you bring it down this way, you say you still break it down. Now you see hydrogen is carrying a partial positive charge, while this other one is carrying out a partial negative charge. Now when you want to solve, you now solve for carbon. So you say carbon plus 3 oxygen is equals to minus 2. Carbon plus 3 open bracket minus 2 is equals to minus 2. Carbon minus 6 is equals to minus 2. Carbon, when you carry this to this other side, becomes equals to minus 2 plus 6, which is going to be equals to plus 4. So you see, it's the same thing with what we got the other time. So that is how knowing the polyatomic ion chart helps you also to find the oxidation number. And by the way, when you broke it to this level, you already know that carbon has an electronegativity value of 2.5, while oxygen has an electronegativity value of 3.5, making oxygen to be partially negative and carbon partially positive. So that's why you calculate, and you see partially positive carbon has a plus 4 oxidation number. Finally, we have this particular compound. Now, how can you find the oxidation number of iodine in this compound? Feel free to pause the video and try. So we know that iodine, right, has an electronegativity value of 2.1. Sorry, this is shows with iodine, like in the chart we gave earlier, has an electronegativity value of 2.5, not 2.1, 2.5. While bromine has an electronegativity value of 2.8. Therefore, bromine is partially negative and iodine is partially positive. Right? Now, we are finding the electronegativity value of what? Iodine. So we say iodine plus 5 bromine is equals to 0. So we say iodine plus 5, and we know iodine is a halogen, therefore it carries what? A negative 1 charge is equals to 0. Iodine plus, this will be iodine minus 5 is equals to 0. Iodine, or you carry to this side, becomes equals to plus 5. So this is so friends, please do subscribe, hit a like button, and please share. And we love to hear from you. We want to hear your comments, please. And if there's a particular subject you are not understanding and you want us to help you out, please feel free to write us in the comment section below, and we will be glad to attend to it. And please hit the subscription button. Thank you very much for watching.